proposed electrical design raises concerns regarding code compliance and electrical safety. According to National Electrical Code Section 225.33b, the equipment grounding conductor must be extended to all branch circuits from the service panel to the new generator panel. Furthermore, Section 110.10c states that ungrounded conductors may not be run through another enclosure, in this case, the service panel. Allowing generator power to run through the service panel creates a potential for backfeed, which can energize utility lines and pose a safety hazard to utility workers and emergency responders. By not extending the grounded conductors to the new panel, the grounding system for the emergency circuits is incomplete. This can compromise the safety features of ground fault circuit interrupters and other protective devices. The proposed design violates the National Electrical Code and poses electrical safety risks. The correct approach is to firstly install a separate transfer switch with an isolated bus for the generator power. Secondly, extend both the grounded and ungrounded conductors from the new generator panel to the transfer switch. Thirdly, ensure that the transfer switch is interlocked with the main service disconnect to prevent simultaneous connection of utility power and generator power. This solution ensures that generator power does not flow through the service panel. The grounded conductors provide a complete ground path for the emergency circuits. The transfer switch interlock prevents any possibility of backfeed. When installing a transfer switch and generator panel, several key considerations ensure safe and code-compliant installation. It is crucial to understand the function and components involved, as well as the specific requirements outlined in the National Electrical Code, or NEC. The transfer switch serves as the central point for switching between utility power and generator power. It should have an isolated bus to prevent generator power from inadvertently flowing through the service panel. The generator panel is where the emergency circuits are connected, providing power to essential loads during a power outage. Proper grounding is paramount for safety and the correct operation of protective devices. The equipment grounding conductor must be extended from the service panel to the new generator panel to ensure a continuous ground path. Ungrounded conductors, or hot wires, should not be run through another enclosure, such as the service panel. This practice can create a potential for electrical faults and compromise safety. The potential for generator power backfeed is a significant concern. Backfeed occurs when generator power flows back into the utility grid, energizing utility lines and posing a risk to utility workers and emergency responders. An incomplete ground path can also compromise the safety features of ground fault circuit interrupters and other protective devices. Ground fault circuit interrupters rely on a complete ground path to detect ground faults and trip the circuit, preventing an electrical shock. The correct approach involves installing a separate transfer switch with an isolated bus for the generator power. This prevents generator power from flowing through the service panel. Both the grounded and ungrounded conductors should be extended from the new generator panel to the transfer switch. This ensures a complete circuit for the emergency circuits and provides a path for fault current to flow back to the source. The transfer switch must be interlocked with the main service disconnect to prevent simultaneous connection of utility power and generator power. This interlock ensures that only one power source can be connected at a time, preventing backfeed and other potential hazards. National Electrical Code Article 700 covers emergency systems, including transfer switches and generator panels. It outlines specific requirements for the installation, wiring, and protection of these systems. National Electrical Code Article 701 covers legally required standby systems, which are similar to emergency systems but may have different requirements. National Electrical Code Article 702 covers optional standby systems, which are typically used for convenience and may have fewer requirements than emergency or legally required standby systems. When selecting a transfer switch, it is important to choose one that is appropriately sized for the load it will be serving. The transfer switch should be rated for the maximum current and voltage of the emergency circuits. The transfer switch should also be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. Proper wiring practices are essential for safe and reliable installation. All wiring should be done in accordance with the National Electrical Code and local electrical codes. Conductors should be sized appropriately for the load they will be serving and should be protected from overcurrent by fuses or circuit breakers. All connections should be made tightly and securely. Proper grounding is critical for the safety and performance of the emergency power system. The equipment grounding conductor should be sized and installed in accordance with the National Electrical Code. Grounding electrodes, such as ground rods or ground plates, should be installed to provide a low impedance path to ground. Regular inspection and maintenance are essential for ensuring the continued reliability of the emergency power system. The transfer switch and generator panel should be inspected regularly for any signs of damage or wear. The generator should be tested periodically to ensure that it is operating properly. Batteries should be checked and replaced as needed. It is also important to keep the area around the transfer switch and generator panel clear of obstructions to allow for proper ventilation and access for maintenance. Proper documentation is essential for the emergency power system. A wiring diagram should be created showing the connections of the transfer switch, generator panel, and emergency circuits. A list of emergency loads should be maintained, showing the power requirements of each load. A maintenance schedule should be established and followed to ensure that the system is properly maintained. When working with electricity, it is important to take all necessary safety precautions. Always disconnect power before working on electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity and take steps to avoid them. If you are not qualified to work on electrical equipment, hire a licensed electrician to do the work. A licensed electrician has the training and experience necessary to perform electrical work safely and in accordance with the National Electrical Code and local electrical codes. They can also help you select the appropriate equipment and ensure that the installation is done correctly. The design considerations for transfer switch and generator panel encompass several critical aspects to ensure a safe, reliable, and code-compliant emergency power system. The location of the transfer switch and generator panel is a primary consideration. These components should be installed in a readily accessible location protected from the elements and with adequate ventilation. Accessibility is crucial for maintenance and troubleshooting, while protection from the elements prevents damage and ensures long-term reliability. Proper ventilation is necessary to dissipate heat generated by the equipment, especially during extended generator operation. Load calculations are essential to determine the appropriate size of the transfer switch and generator. A thorough assessment of the emergency loads is necessary to calculate the total power demand during an outage. This calculation should include both the continuous and surge power requirements of each load. The transfer switch and generator should be sized to accommodate the maximum anticipated load with some additional capacity for future expansion. Overcurrent protection is a critical safety feature that protects the emergency power system from overloads and short circuits. Circuit breakers or fuses should be installed in the transfer switch and generator panel to protect each branch circuit. The overcurrent protection devices should be sized according to the ampacity of the conductors they protect. Grounding and bonding are essential for electrical safety and to ensure proper operation of protective devices. The transfer switch and generator panel should be properly grounded to a grounding electrode system. All metallic enclosures and non-current carrying metal parts should be bonded together to create a low impedance path for fault current to flow back to the source. Wiring methods should comply with the National Electrical Code and local electrical codes. Conductors should be sized appropriately for the load they will be serving and should be protected from physical damage. Wiring should be installed in conduit or cable assemblies that are approved for the intended application. Control and monitoring features can enhance the functionality and reliability of the emergency power system. Automatic transfer switches can automatically switch between utility power and generator power upon detection of a power outage. Monitoring systems can provide real-time information about the status of the generator, transfer switch, and emergency loads. These features can help to ensure that the emergency power system operates as intended during an outage. The National Electrical Code provides detailed requirements for the installation of transfer switches and generator panels. Compliance with the NEC is essential for ensuring the safety and reliability of the emergency power system. Local electrical codes may also impose additional requirements. It is important to consult with a qualified electrician to ensure that the installation complies with all applicable codes. The electrical installation process involves several steps, from planning and preparation to final testing and commissioning. A detailed plan should be developed that outlines the scope of work, materials required, and installation procedures. The plan should be reviewed and approved by a qualified electrician. Before starting the installation, all necessary permits should be obtained from the local authorities. The installation should be performed by qualified electricians who are familiar with the NEC and local electrical codes. Upon completion of the installation, the emergency power system should be thoroughly tested to ensure that it operates as intended. The testing should include verifying the proper operation of the transfer switch, generator, and emergency loads. The results of the testing should be documented and kept on file. Regular maintenance is essential for ensuring the continued reliability of the emergency power system. The transfer switch and generator should be inspected regularly for any signs of damage or wear. The generator should be tested periodically to ensure that it is operating properly. Batteries should be checked and replaced as needed. A maintenance schedule should be established and followed to ensure that the system is properly maintained. The National Fire Protection Association, or NFPA, provides additional guidance on the installation and maintenance of emergency power systems. NFPA 110 covers emergency and standby power systems, while NFPA 70, the National Electrical Code, provides detailed requirements for electrical installations. Consulting with a qualified fire protection engineer can help to ensure that the emergency power system complies with all applicable NFPA standards. Several common mistakes can occur during the installation of transfer switches and generator panels. One common mistake is undersizing the transfer switch or generator. This can lead to overloading and damage to the equipment. Another common mistake is improper grounding or bonding. This can create a shock hazard and prevent protective devices from operating properly. Failure to comply with the National Electrical Code and local electrical codes is another common mistake. This can result in safety hazards and code violations. Working with electricity can be dangerous. It is important to take all necessary safety precautions to protect yourself from electrical shock and other hazards. Always disconnect power before working on electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards of electricity and take steps to avoid them. If you are not qualified to work on electrical equipment, hire a licensed electrician to do the work.